What I would like to talk to you about right now is sourcing an R script. And so this is an action that I think most of you will be familiar with once you see it. It will make a lot of sense to you once you see it, and it's something that you could probably figure out on your own, but it's also something that gets done a couple times early on in the workshop, and so I thought it would be nice to make a video about it. The first thing that I'm going to do, because I do like repetition, is that within my RStudio environment, I'm going to start a new project, just so you guys can see once again how that happens. So new project, I'm going to make it in a new directory, sorry, but I'm going to make this new project part of my R course for the NOAA Human Dimensions folks, and I'm going to call this sourcing an R script. So that creates my new local project in RStudio. And now I'm going to make my script. So I'm going to go new file and I'm going to go R script. And so my abstract motivating example here may not be the best example, but it's a real example from my work. And so I thought I would like to provide it here as a little bit of motivation for why sourcing a script can sometimes be beneficial. And so let us imagine that we have two database tables and that we're comfortable enough in R to work with those tables on the database. And what we like to do is join two tables, one of them containing commercial fish landings. And this is a table that might have the following fields: a date, a vessel, a port name, and a pounds. And so you can imagine that this table would be populated with observations from commercial fishermen who return catch at different ports at different days and times, and this table would probably get updated or refreshed on a fairly regular basis as new landings come in. Okay, and to this table, we would like to add some georeferenced information. So in another database table, there are some port locations. And this port locations table would have the following fields: port name, so you can match between these two data sources using the port name, and the latitude and longitude coordinates of the ports. And so if we have some analysis that gets done with these data that, say, joins these two tables together and brings the results of that join down into an R workspace, and then does some analysis with the resulting data, we might like to have that data pull separated or partitioned out from our script that does the analysis. The data get updated frequently, so we would want to rerun the data importing portion. So we might want to have a script that pulls these data down, joins them, and cleans them up a little bit, and makes them ready for analysis. And if we did have a script like that, we might want to use that in several pieces of analysis, because in my own work I have lots of different analysis that gets done on the same data sets that get updated frequently. So I don't want to have to rewrite the same lines of code over and over again to import some data, joining it on the database side, joining two database tables together, bringing that into the R workspace and cleaning the data up. So I might write a script that does that, so that each subsequent piece of analysis that wants to use those data can just run that script and have the data available to it. So that last part was a rather long preamble on sort of a philosophical case or an abstract case where you might find yourself wanting to write an R script, and you might find yourself wanting to source that script in order to make the results of that script available to you in another script or in another R environment. So right now I'm going to try to provide a minimal kind of working example, and I think you can all use your imaginations and imagine much more complicated and interesting cases where you might want to do something like this, but I'm going to give you sort of the minimal reproducible unit here, which is that, as we sort of talked about in the abstract case where I was drawing from an imaginary database, here I'm just going to create those data frames, but I'm going to imagine that we have a data frame on port locations, and this has georeferenced coordinates of fishing ports and the names of those ports, and then we have some landings. So we have some commercial fish landings at those ports. Totally imaginary, but those landings come in the form of dates, vessels, and port names. And so I'd like to take these landings data. And one thing I forgot here was the actual landings. So let's create pounds, and let's let pounds have some imaginary values. 350. And so in this script, I have two I have two data frames. I have locations and landings. And then what I'd like to do is create landings as, let's start with port landings, and let's do a left join. Let's left join port locations. And let's do it by port name. So now I have, important that I import the necessary libraries here. So let's do that. Oh, I did not make this a data frame. So let's make it a data frame. Data frame has a date, a vessel, port name, pounds. Did I properly end it? Yes, I did. So now it should work. I should have a data frame, and then let's say for a little added realism, let's say that landings, this date is a character variable, and let's say that when I want to work with it, I'd like it to be a date class variable. So now I'm going to mutate date as date format, so year, percent, month, day, year. Now we're going to do this all again, and landings now is a date class variable. So all I have here is a script that takes two data frames, joins them together, creates a data frame called landings. And as I mentioned in the last section, if this is sort of a repetitive action that we might want to do, such as if we were interacting with a database that was getting updated frequently, we might have another piece of analysis. So before I get ahead of myself, the first thing that I should do here is I should save this to my project, and I'll save it as data pull. I'll save it as datapull.r, and then we can see that script down here in my project. So with datapull.r, maybe now I have a new R script, and we'll call this script data analysis. So this will be data analysis. And within data analysis, I want the data from data pull to be available. So one thing I can do, it's probably good, I can see that these are in the same directories, but it's nice to do this step sometimes, just to, particularly for anyone that's kind of just getting started out. We'll provide a few more examples of ways that you can just kind of navigate these working directories and get some fluency with working directories, get WD. So my current working directory is this R project called sourcing an R script. And if I list the files, I have two R scripts, data analysis.r and data pull.r. And so one thing I can do here, before I do this, let me clear my workspace. So if I clear my workspace now, I don't have any variables in my global environment. So we had over here in data pull, when we ran this code, we had landings, we had port locations, we had port landings, and then we had landings, right? And so I just want to demonstrate that we do not have those objects currently in the workspace because I cleared out the workspace. So we're dealing with a workspace that's currently empty, right? But if inside this data analysis script, my source data poll.r, what's going to happen if I source this is that it's going to run that script, which means it's going to create those 3 data frames. And then let's do this piecemeal first. So source data poll.r, run it, and once I've sourced that script, it ran that code and it created for me these objects. So let me add one line here, just for realism. Landings, y equals pounds, color equals port name, and let's do this. Right. Again, we have to remember to load the libraries that we want to use. So if I load that library and I run that code chunk, I'll create a plot, okay? And to just kind of really tie a ribbon on this, let's again remove everything from the workspace. So the global environment's empty. This is my data analysis.r script. So in our imaginary world, we can imagine that this would be a script that would do some more complicated analysis on a piece of data or on some data that may be getting updated frequently. So rather than embed a data poll and a data massage line or lines of code into our analysis script, I'm just going to keep my analysis script clean, and it's just going to source a data poll script, and then it's going to do some stuff to the data, right? And so again, working with this empty environment, right? If I load the library, then I source that data poll script, and then I run my code. It's going to populate the workspace with the objects that are created in this data poll script, right? And it's going to create for me my plot, which is not a very interesting plot, but again, I think this gives us the minimal working example to sort of demonstrate for you what is meant by sourcing a script, and a little bit about how it can be beneficial. The final thing I would like to do here is just show you guys what this looks like when it's done in a non-trivial environment. So I'm going to open up my data visualization project, and within my data visualization project, I have one .rmd file. So I have an R Markdown file that does some analysis on some data and then creates a map. And what I'm looking for here is my COVID-19, my California county map, COVID-19 cases. And what I would like to show you first is what the output looks like, and then I'll show you how sourcing a script is sort of an integral part of the process. And so let me just knit this very quickly so that you can see the rendered HTML because it provides a nicer visual than looking at things within the RStudio environment. And then while that is rendering, I will go ahead and open the R file that we'll want to look at. So now what I'd like to call your attention to from this HTML file that's rendered is the static county map for California. So this is kind of the payoff. I have a lot of data importing and some data manipulation that's happening behind the scenes. I have a little bit more data manipulation that happens within the .rmd document, and then it all comes together to produce a pretty simple heat map of new COVID-19 cases in the rolling 14-day windows, and it's measured in cases per 100,000 residents. So the reason that I wanted to show you this output is that the way that this output comes together is within this .rmd here. Okay, one of the first things that happens, not the first thing. So the first thing is that my necessary libraries are loaded in. And then the next thing that happens is that there's a line here, source. And so I'm sourcing this R file, this .r script, right? Let me pretty this up a little bit. So this is that familiar source line that we just went through. And in this file, this R code here, data clean.r, I've embedded a fair amount of code that basically pulls the updated COVID-19 data at the county level from a CSV file that's hosted on GitHub, and it's updated frequently. So I've nested this in a script. The first line of the script pulls the data in, so it's going to pull in the refresh data, and then it's going to do a lot of other stuff. And it's not important really that you understand all the other stuff that it's doing. I've got some county boundaries that are taken from a shapefile that are also getting read in this step, and then county populations from another CSV file that are getting read in here. And then there's a lot of stuff that's happening to this data. These three data sources that are getting pulled in are getting joined together, and they're getting manipulated. And at the culmination of this script, right, I have a couple of data frame objects that have been created that allow me to do some analysis on COVID-19 cases at the county level in California. And so what this script is doing basically is allowing me to keep my .rmd document clean. And it's not the cleanest document that's ever been produced, but I think you can read through it in a way that's not overwhelming, such as might be the case if I had taken all of the data manipulations and data import from here and embedded them in code chunks within this RMD document. I think there's a slightly cleaner flow that's allowed when I'm able to just source the data, meaning that it's going to execute this script, which is going to pull data, clean it up, make that data available in the workspace, and then I can do a couple of final flourishes on the data, one last mutation here, and then plot the data. And actually, I have a couple other visuals, so I have a bar chart that's happening as well. And so this is sort of a non-trivial example of a place where sourcing a script can be a nice way to kind of organize things, in the sense that it allows you to have an analysis document that's relatively clean because it's not cluttered with a lot of data importing and data manipulation